Hello everyone, and welcome to this chapter. In this chapter, we're going to discuss concurrency in Dart. What is concurrency really, if you're thinking of it as a programmer? To put it simply, concurrency is the ability to be able to execute code simultaneously. So when you are writing your code, your code doesn't necessarily have to follow one branch from the beginning to the end, except it can go into its own branches, or pipes, as I like to call it, and order those pipelines and execute those pipelines at the same time. Now, modern computers have the facilities to execute code simultaneously. And this wasn't a possibility many years ago, for instance, to have a hardware support this. But today's hardwares, they're, for instance, if you look at a CPU, I'm not a hardware engineer, but I know enough about hardware to be able to say these things. But if you think, for instance, you have an Apple's M1 or M2 CPU, or you have Intel's CPUs, and you have in these CPUs there are cores, so there are physical cores actually operating inside the CPU, and it has nothing to do really with if you're familiar with Intel's naming convention, Core i5, Core i7, Core i9. It has nothing to do really with that naming per se. But modern CPUs, they have cores, and you have to think of it as just like a pipeline of code execution. And then these physical cores themselves then can have the ability to execute threads. And these threads aren't necessarily bound to the same threads as you may be aware of. For instance, in the operating system terms, that you have the ability to create a thread. Or in Dart, the ability to create an isolate, which is something like a thread. So you have to kind of be familiar with these terms in order to be able to understand how threads work internally, like inside a modern CPU. But you don't have to know exactly how it works. It's just that I think it's important to understand the difference between, for instance, a thread supported by a CPU and a thread supported by an operating system, whereas a thread in an operating system is kind of like a virtual asynchronous execution context. And a thread that is supported by a modern hardware, a CPU, is a unit of computation that can perform work independent of other threads inside even the same core. So I suggest that you actually have a read about, that's kind of like the outside the scope of this chapter. But I suggest that you have a look at modern day CPU architecture, and have a look at like processes and threads, and also have a basic understanding of what threads inside of an operating system mean, and how they're different from threads of a CPU's core, for instance. So Dart has support for modern concurrency. And if you're familiar with programming languages like Rust, for instance, if you're using Tokyo with Rust, or if you're using Swift's new concurrency architecture, JavaScript and React, any of those modern SDKs and languages, they have support for modern concurrency with async and await. Now, that's one of the core parts of Dart's concurrency model, using async functions and then using the await keyword in order to wait for the response of an asynchronous function. So we're going to talk about these in this chapter. So don't worry if you're not familiar with async and await in Dart. I'm going to do my best and explain how they work in Dart, how you can take advantage of them. So we will have a look at quite a few examples actually in this chapter. I think we'll talk about it, maybe about, I think, 9 examples of concurrency in Dart, and we'll actually build like a sample application that works with those concepts of concurrency within Dart. So we're going to talk about streams, and I think just touch upon stream groups a little bit. We're not going to have a look at an example of stream groups, but I'm just going to explain stream groups just briefly, and then let you explore that on your own at the end of this chapter. So let's go ahead and set up our project first, like we usually do. And I'm going to do some reshuffling on the screen here. Let me bring up Terminal. Just adjust my microphone a little bit here as well. So let's go ahead and create the project then. I'm gonna increase the size of the font as well quite heavily, so you see it even if you're on a mobile device. Let's say Flutter create, and I'm gonna say concurrency, and I'm just gonna append underscore course to it because I already have this folder. To my left-hand side, I've already prepared all that code, and I've named that concurrency, this project, which is in this exact same folder. I'm creating this project, so that's why I'm appending an underscore course to it, but you're free to not do that if you don't want to. And I like to also specify an organization. Let's see if I can fit this inside the screen like this. Also, you don't have to specify the organization. This is just something that I prefer to do. And I can see that there's a new version of Flutter as well available. So I'm not going to update Flutter right now. That's going to take a while. So let's just go ahead to our project. So I'm just going to say concurrency course, and I'm going to bring up Visual Studio Code. And perhaps while this is going on, let's update Flutter as well, Flutter upgrade. Okay, so let that do its work in the background. Okay, let's open up Visual Studio Code. I'm going to increase the size here also quite heavily. And let's go to our main Dart file in here. Okay, so I'm going to reload this. I see that there's lots of stuff coming up here just because Flutter is like rebuilding. The Flutter daemon has terminated. That's completely fine and understandable while we're upgrading Flutter. So for this chapter, we're going to use, as we're developing asynchronous code, we are also going to need the live server extension in Visual Studio Code. And this is one of my favorite extensions in Visual Studio Code because it allows you to turn your current project into a live server. It allows you to, it deploys a local web server in your computer serving the contents of your current project, meaning that you can, for instance, have some mock APIs in your project. So that's exactly what we're going to do in this chapter. And we're going to create some mock APIs that simply return a JSON, and we're going to place them inside our current project. Okay. So let's go ahead and take care of that and install the live server extension. And at the same time, I can see now that a Flutter upgrade is complete right here. So we could basically reload our environment in here. So I'm just going to close Visual Studio Code and then bring it up again like this. Perfect. And I think I also have a live server running in another environment. So I'm just going to stop that so that I can have live server on this Visual Studio Code instance right here. Great. I think we can close our terminal as well. Great stuff. Let's go ahead and set up live server. So I need you to please go to extensions and search for live server, as I'm doing right here. And it's a free Visual Studio Code extension, and you can just install it if you haven't already. I've already done that. That's why I'm getting this disable button right here. Okay, so after installing live server, you don't have to take any action. You just need to install it. And we're going to go ahead and create our app scaffold. Okay, and I have a very handy snippet in Visual Studio Code that sets up my app scaffold because I'm not a big fan of the default app scaffold in the default Flutter applications app scaffold in the template. So I have an FSA snippet in here, Flutter scaffold application, and it creates a simple scaffold for me. And it has a homepage stateless widget, and it has a build function with a scaffold and an app bar, and that's really that's all it does. It just creates the run app and the material app inside the main function. So I've created a YouTube video about this. So if you want to go and watch that video, please go ahead and do that. It just allows you to create simple snippets in Visual Studio Code, so you don't have to repeat your stuff every time you create a new Flutter application. Okay. Let's go ahead and also add some logging functionality to our application. I mean, for those who know me, I really like to use development dev tools in Dart to do logging instead of using print, because print is discouraged from using in production applications. So I also have a good little snippet for that. So import Dart developer and then make sure it's prefixed with as DevTools and only show the log function. And then we have an extension on object that just allows you to log any object to the console. So that's the code for it if you want to go ahead and do that at home as well. Okay, so what we're going to do in here is to go ahead. Actually, if you go back to our setup live server extension, that's where we need to set up the API for our application. So let's go ahead in our project and create the API. I'm just going to say new file in here, and I'm just going to say API, as you can see at the bottom of the screen, and then people.json. Okay. So let's go ahead in here and then add our people JSON. I'm going to have a look here if I can like paste that so that I don't have to type it. So here's the contents of people JSON. Okay, it has nothing special really. It's just an array. It starts with an array, as you can do in JSON. The main, the body of the JSON is an array, and then there are two objects in here: foo age 20 and bar age 30. So that's our people JSON. Then we're going to go to the command palette in Visual Studio Code and say live server. And you can see it says open with live server. Okay, so live server is running. I can see in here, I'm going to bring up this, as you can see, after starting live server, it is serving my local development folder on a web server. And then we have the API folder, and inside we have people JSON, as you can see. So that's what live server does for you. Okay. So for this person object, now we have to go ahead and create a person class. And we're going to use this person class in our Dart application or in our Flutter application here quite extensively in this chapter. So it is worth the investment of time into creating a good person class in here. Okay. So let's go ahead and create the immutable class person like this. And we're going to add a final string name and a final int of age. So final string name and final int age in here. And I'm going to get help from Visual Studio Code to create a constructor for this and make these required parameters. So doing this, make sure that these two parameters are not only required, but they're also named required parameters. Okay. So that's our little person class. And also, since we're going to do some JSON parsing, we need a constructor on this class that can construct an instance of the person class given a JSON map. So let's go ahead and say person from JSON like this. And then we're going to take a map of string dynamic. Okay. And we are going to call it JSON. And in here, we're going to just initialize our person class. So we're going to say name is equal to JSON, and we're going to look for the name key as a string. And then we're going to say age is JSON age as int. Okay, so that's the constructor. I mean, you could say it's kind of like a factory constructor, kind of. Now that we've done that, we're also going to go ahead and implement the toString because we're going to use some logging in this chapter, as you saw from our log function. And for that, we need person to basically implement its toString function. So let's go ahead and write toString in here, and we get help from Visual Studio Code to complete this. It will be an arrow function, and I'm just going to say person in here and $name, $age, years old. Okay. Just like that. So it's a very simple implementation of the toString function of our person class. All right. Now, what we need is to define the URL of our person or people JSON. And I've already defined that, so I'm just going to paste it in here. So it's a constant URL, as you can see. And if I command click on it, it should actually, it went to APIs. All right, because we've defined API. All right, so that's just a little bit of a mistake. Either we change the URL or we, yeah, it's probably best to change the URL. Let's just call it API, okay? So that we can follow along. Because this folder is called API and the file is called people.json. So this URL also should point to API people.json and it should lead here. Okay, that's really good. Now we've defined that URL. Now what we're going to have to do is to create a function that actually parses this little URL for us. So given this URL, then this function can parse its contents and send us an iterable, or you would say a list perhaps. We're going to use iterable in this example of person instances. Okay, so let's go ahead and do this parsing. This is going to be quite interesting. Okay, so now this is like the first case in this chapter that we're going to talk about asynchronous programming indeed. So you have to think about now that we have a URL and we have to call that URL, grab its contents, parse it. So there's lots of operations that need to happen, about 5 or 6 lines of operations. These things cannot be synchronous. Synchronous operations mean that when you call a function, it will immediately calculate something and the result will be immediately available by the end of that function's execution. However, asynchronous functions don't work like that. Asynchronous functions usually return a future. So what that really means is that a future in Dart denotes the capability of a function to not return synchronously and immediately, except return some value in the future, as the name indicates. So by prefixing the data type of what your function intends to return, in this case, an iterable of person, with a future of iterable person, your function denotes to its caller at the call site that, hey, I'm going to execute some code asynchronously, and I'm going to return the result to you. So let's clear some of these misconceptions up. A lot of people have asked me, what is the difference between a function that is marked with async and a function that returns a future? They both kind of achieve the same thing, except that a function that returns a future doesn't actually calculate its contents inside the function itself, except the function that is returning a future is packaging the execution code to be called by the caller later in the future. It's a little bit strange. I'll explain it soon as we see the example. Whereas a function that is marked as async, what that function does, it says, hey, caller, whoever's calling me, I'm actually asynchronously going to call some stuff within this function, and will await on the results before I can give my results back to you. So it's two different ways of looking at the same thing, and we'll get to know this concept more and more throughout this chapter. So let's go ahead and first define this function that we want to implement. What we want this function to do is to say, hey, we are going to write the code that is capable of returning an iterable or a list of person objects. But this function itself is not going to calculate that return value for you. It's going to package it into a future, and you have to read its contents. Okay. So let's go ahead and say future of iterable person. So that's the result of this function. Some iterable or a list of persons that needs to be awaited on by the caller in order to unwrap its data. And we're going to call this parse JSON, as you can see. Okay. And as you see, this function is not marked as async. That's what I meant. This function is only going to do the calculation of the return, which is the iterable person. This function in itself is not going to await on anything asynchronous to happen. If a function returns a future, it's making its caller await on the result. If a function was marked as iterable person async, then this function itself would await on the result and return that result to you, iterable. Okay, so let's go ahead in here and just say future iterable person. And what we need to do in here is to create an HTTP client first. Okay, so this is, I've explained this in my free Flutter course quite extensively, how we work with HTTP clients. Well, let's go ahead and execute its get URL HTTP client. I think we have to actually import Dart.io to get access to HTTP client. As you can see, import Dart.io. Now we have access to HTTP client, and then I'm going to say get URL. URI parse URL. Okay, so that's the get. Then this get URL itself, as you can see inside its function signature, it itself returns a future. Now, if you're working with futures in Dart, there is a really handy way of chaining different futures. So when you're thinking about asynchronous programming in Dart, you need to always think in pipes. It really helps. I mean, I got introduced to asynchronous programming and with reactive programming, actually, not just asynchronous programming. Asynchronous programming, I was exposed to it very early, but reactive programming I got introduced to about 6-something years ago, I think, or more, I would say initially. What you need to think about when you're thinking about reactive or asynchronous programming is it really helps if you think in pipes. And what that means is that you need to think about the flow of data. And when I say flow, I really mean just like water. So you need to think that here's a client. Just imagine a pipe in your head, and you say, this client is getting a URL. So that's, let's just say it's a pipe of URL. Okay, just imagine a water pipe, and only thing flowing in that is a URL. And then you say, okay, but what is the result of this pipe? You can see it's a request. So you'd be like, okay, so this pipe is not really the URL. It's actually a pipe of the request. Okay, so here's a request pipe. All right, how do we get the response out of that? Well, yes, there is a function on this pipe that allows you to close this request, and in turn, it gives you the response. However, that function called close isn't available on the pipe itself. It's available on the data in the pipe, which is the request. So in order for you to be able to go in that pipe and execute that close function, you have to actually do some magic. And then magic with future inside Dart is done using the then command. So if you type then in here, what you're doing is saying that, hey, the pipe of request, I want to go in this pipe and access what's in it. That's what the then function does. So we know that this then is going into that pipe of request. So we just type request. Okay, so that's the request. Then what is expected from you when you execute the then command or the then function, if you look at its signature, it says you either give me a future back or a value. So in here, you could just type hello, okay? And you're getting an error in here, that's okay, but that error is simply saying that you said that you're returning an array of persons, but you're not. So let's just say list of person empty. Okay, so now you see it's happy. It's like, yeah, you went into this request pipe and you didn't even touch the request itself. You're just returning a list of persons, which is empty. And Dart is quite happy about that. It's like, okay, you said you're returning a pipe of a list or iterable of person, and you're doing that. You're actually returning an empty one to me. So what you did in here is that you went into this pipe of request and you created a new pipe from that. So you went into it and you created a new pipe that returns an empty list of person. That's it. However, that's not what we're going to do in this function. What we're going to do is to actually do something with this request. And what we're going to do is to call this close function. Now let's have a look at this close and see what it actually returns. You can see it returns another pipe, a future of the response. That's great because we went into this pipe of request and extracted its value, which is the request, and went and created another pipe using the then function. And we said, okay, here's another pipe of the actual response. So this pipe of request stays right there. You extracted this response and you created a new pipe using the then command. So that's one pipe, okay? And this is your new pipe here, which creates the response and gives it to you in a new pipe. And then the question is, what do you want to do with that pipe? So now that you have that pipe, you know that you want to go and grab its value and do something with it. So what we're going to do in here is to chain this with another pipe. So we're going to say now that we have the response, let's call it response like this, or resp, we actually want to basically get the string out of this, okay? And to do that, we need to have some conversion utilities imported into our code. So let's go ahead and say import. I think is convert, Dart convert, yes. Let's go back in here into our response. And what we want to do is to say response.transform, okay? And this transformation, we need the UTF-8 decoder, okay? And then we're gonna join this whole thing. All right, let's see what happened here. So you'd be like, oh, I didn't understand this part, and that's completely fine. I'm just gonna break it down a little bit here to make it a function. You don't have to do this. I'm gonna assign this to foo, and let's see what the value of foo actually is. Now you can see foo is a future of string. Interesting. So first we had the pipe of the request. Then we went in that pipe, extracted the request, and then, as you can see in here, then we closed the request. It created a new pipe of the response. Then we went with the second then clause into that response pipe, which is the second pipe, and we said, okay, hey, response pipe, transform your data into a UTF-8 string. As you can see, it becomes a string in here because when you transform this, you can see it returns a stream. And then when you call the join function on that stream, it actually returns the future. Okay, so there's quite a lot of magic happening in this line. And that's kind of like outside the scope of this course, but or this chapter. But what is essentially happening in here is that you're taking the response and then you're dumping its data into a string. But that's not happening synchronously, it's happening asynchronously, meaning that, well, you're in an async context in here. So just return that future, right? So now we're 3 pipes deep because it's kind of like the Inception movie. I don't know if you watch it. So you start with this dream and then you go further in the dream and then further in the dream. So now you had the first pipe, which was the request. You dug deep in it and you took the request and then you closed the request, creating a response pipe. So you came into a new pipe in here. You went into this response pipe and then transformed this data into a string. So now you're in the third pipe, which is going to give you a future of string. Okay, so after this pipe, what are we working with? We're working with a string. Every one of these then clauses changes the data type of your original request. So think again in pipes. You start with the request pipe, you then get the response pipe, then in here you take a string from the response. So the result of this pipe at this moment is actually a future of string. And you can prove that by making this not an error function, but instead having a normal function body, and in here say final foo is equal to this. And then if you get the data type of foo, this is actually a future of string. So every then clause that you add to your future is actually changing the data type of the result. So imagine you have the ball up here, and then the ball just keeps dropping, and then comes to the football player in here, which gets the ball, which may be a completely different color. So you start with something and just keeps dropping, and then you get the result in here, which could have a completely different data type. So let's go back then to how we had the error function. So you know that after this then clause, we have the future of string. Okay, you know that you can work with futures using the then function, which then goes into that future, grabs its data, and allows you to change that data into another data type and do some transformation on it. And what we're going to do is to actually do some JSON decoding in here. So that's also available in Dart. And I'm going to go ahead and say then, okay, and this is our string, okay, and we're going to say JSON dot decode this string, and this is going to give us a list of dynamic, all right, and now that we're doing that, I mean, the result of this then clause is in fact a list of something, a list of dynamic, okay? And then we're gonna say then, again, you see, in here, this is our JSON. And if I move my mouse over it, you'll see that this should say this is a list of something. Okay. Then what we're going to do instead in here, if you remember our JSON, let's go to the people JSON. That list of dynamic is in fact a list of map of string dynamic. Okay. But we call it list of dynamic because we're just not going to put the burden on Dart to actually type check this all the way. And now that we get the JSON, we're going to map it, meaning that every object inside this list is then going to be mapped or changed to another object. Okay, so in here, we're just going to say person dot from JSON e. And now you can see that Dart is quite happy about this. So it's just like, yeah, this is fine. So let's have a quick look again what happening here. We created is an HTTP client which in itself is just a class, is not doing anything asynchronous, nothing special is happening with it. So you'd be like, how can a future of iterable a person start with something that's not a future? And that's completely fine, because I mean, the beginning of this function doesn't necessarily have to be a future. It could be the class that does create the future for you. And that's what matters. So that's just normal Dart code execution. The get URL is the function, the first pipe, which actually creates a future, which is the request. We then take that request and create a response out of it. From the response, we parse it as a string. We take the string and parse it as JSON. Then the JSON is split into various instances of this person class, which in turn becomes an iterable of that class. So the result of this really is an iterable person, but the result of the entire thing is a future of iterable person, right? Because if you look at this code in its entirety, there is nowhere in this code that you're actually waiting for the result. What you're saying is just hypothetical code that is working with pipes. So it's saying, given a pipe of this request, I'm going to grab its request, make a response, etc., etc. So it's just the definition. It's really not the code that's actually doing the current work. It's not executing the asynchronous work right now. It's just saying, I pack this asynchronous work and give it to you. It's your turn now to actually execute it. So remember this, when a function returns a future, it doesn't necessarily perform the actual work itself. It is giving you the ability to perform that work in the future yourself, hence the name future. All right. Now that we've created this, let's go ahead and add a function here. I'm actually going to move this function a little bit lower. Perhaps I'm going to put it after all this person class and stuff. I'm going to take that and bring it at the bottom of the main function, so it's near to the home page. So you don't have to necessarily do that. I just wanted to do it for the sake of clarity. Let's go ahead and put this code to use, as I've mentioned in here. So we're going to create a little function in here. We're going to call it tested. Okay. Now this tested function wants to actually call this function parse JSON and grab its result. Okay. So let's go ahead and say final persons is parse JSON. Okay. And I mean, I'm intentionally doing it like this. I'm doing it incorrectly. Okay. I just want us to go through this and see how it actually works. I'm going to do select device. I'm going to do the run operation while we're talking about it. Now that we're doing this, let's go say persons.log. Okay. Remember, we have this log function from before. I kind of want just to call that log function and see the result that it gives us. I think it's very important to see the result of calling a function that returns a future without awaiting on it, because you'd be like, okay, yeah, parse JSON, yeah, it should do the JSON parsing now and just return the parse JSON back to us, but that's not really the reality. So the application is running right now. I'm going to bring up the terminal in here. And right, so nothing is getting printed to the screen because we're not calling this test function. So let's go in the build function of our homepage and just call the tested function, okay? Right there. And now you can see the result being printed to the screen. What it's saying is really, it says instance of future iterable person. So what happened in here is that since our function, our tested function in here, simply called this function, what it did is that it got the package. It didn't actually open the package. You see, the function is returning a future, think a package. But what you did is just say, give me the package and print it to the screen. And that's exactly what happened. The package got printed to the screen, not its contents. That's where async and await come into play. In order to open a package or a future or a stream, you need to await on it. You actually now have to wait until you open this package with your knife and you open it and you see what's inside it. That's await. And that's what you want to do in here. You say await. So now you're saying open the package. I know that you return a future, but open it. Then we're having this problem. It says the await expression can only be used in an async function. Try marking the function body with either async or async asterisk. What does this really mean? It means that normal functions in Dart, such as this one that says void tested, they don't have the ability to await on other functions in order to open those packages. These functions that don't have the async syntax in front of them or the keyword in front of them, they're not capable of executing asynchronous work. They're not capable of opening other futures or streams. In order for any function in Dart to be able to even use the await function, it needs to be marked as async. That's where the async syntax comes in play, and it's right there. So what you're saying really to the caller, to Dart in this case, for instance, is, hey, this function is going to do some unpacking of some futures or strings. Hence, it's marked with the async syntax. So in there, then you have the ability to use await. However, we didn't have to do it in here simply because we're not awaiting on anything. You see, there's no mention of the word await in this function. This function is simply doing the work of packaging that content. And this function is unwrapping that package for us, and it's like opening its contents. Hence, it needs the async and await syntaxes in here. So now you'd be like, okay, but we're not actually awaiting on the tested function in here. How does this work? So what's happening in here is that, you see, if I say await, we're going to get an error in here. What is the reason behind it? Any function that needs to use the await syntax here, this, needs itself to be marked as async. Okay, what function are we in? We're in the build function. This function is not an async function. So if I go and say await on this function and then mark this as async, we're going to get a lot of problems in here because a build function cannot be asynchronous. So maybe you're like, okay, but how does this even work? How can this function be called without await and still work? Well, what's happening in here is that we're just calling this function that doesn't return anything to us. But this function itself is marked as async. Dart then understands that this tested function internally is going to do some asynchronous work, but no one's awaiting on any response on it. So we're just firing and forgetting. That's what it means. If you're calling an asynchronous function in Dart without awaiting on it, you're literally firing and forgetting. So you're saying, go do your work, whatever you want to do. If it's asynchronous work, just go ahead and do it. I'm not interested in any result. So remember that, okay? Fire and forget. No results from a void tested async function in here. As you can see, it's actually denoted with void, meaning that it has no results. All right, so now let's see this in action now that we've marked it as async. And I'm going to bring up this and our debug console and just going to do Command S. And now all of a sudden we can see person, foo, 20 years old, person, bar, 30 years old. So now that we're doing await on that future, we're getting the results back printed to the screen, okay? So you need to understand the difference between async and await. Async is a way for you to mark your function as being able to use the await syntax. That's really it. A function suffixed with async is able to use the await syntax. So that's really just a marker for the function. It gives it the ability to use await. Okay, so that's async. And await itself can wait on the result of a future in a function marked as async. Await unwraps the contents of a future. That's really it. So let's go ahead and commit and tag our code in here. So I'm going to go ahead in here and just create a put our terminal up in here. Let's just say git status and git init and git add all like this. Git commit step 1. All right. And then git tag step 1 as well. So that's for the first step of this chapter. Okay, with that example out of the way, it is time that we have a look at something a little bit more complicated, and that is the execution of multiple futures at the same time. So how do we do that? How do we go about issuing or actually calling multiple futures at the same time and waiting on their response? And there's a very handy function on future itself in Dart that allows us to do that, and that function is called wait. So I can show you the signature of that function. We're not going to call it directly, but if you type future wait, you'll see that the function signature itself is defined this way, and it says I can get a list or an iterable of futures of t, and then I can return a future that has a list of those results back. So I understand this may be a little bit confusing to start with, and that's why we're going to go ahead and create an example to demonstrate how future wait actually works in Dart. Okay, and I'm going to break it down into bits and pieces so we understand how it works. So let's go ahead and add another JSON to our API. So I'm going to go ahead in here, and I can see people1 in here. I'm going to copy and paste it. And let's rename this to people2, and let's rename this first one to people1. Okay, let's go in this people1 and then call this foo1 bar1, and let's go to people2 and call it foo2 bar2. Okay, so that's saved then, and the first one is also saved. So just all you need to do is just to make sure that you have two separate JSONs and kind of like make them identifiable as well. So the first one says foo1 bar1, the second one says foo2 bar2. So when we print them to the debug console, they're identifiable. Okay, let's go ahead and define the URLs for these JSON files. As you can see in here, we have URL. Let's go ahead and rename this, and I'm just going to say people1 URL, and that's going to go ahead and do its work. Hopefully we can manage. I think it didn't manage. People1 URL. Okay, now it did. I'm going to copy and paste that, and this time for this one I'm going to say people2 URL and change their URLs as well. So people1 URL and people2 URL. Okay, good stuff. So what we need to do in here is actually change this parse JSON function so that it accepts a URL in here. Okay, because at the moment it's only hard coded to return or use this people1 URL, which previously was just called URL. So let's go ahead and change that. So we're going to say string URL is a parameter, and in here we're just going to say a URL. Okay, and then in here in our tested function, we're going to pass people1 URL for now, just to make sure our code is compilable. Okay, so great stuff. Now what we're going to do is to change our tested function so that it uses the future wait functionality. So let's go ahead in this tested function right here and say future wait. The parameter that we pass to this guy, it needs to be an iterable of futures. Okay, so we're saying the first future is parse JSON people1 URL, and the second is people2 URL. So you can see in here, we're literally saying that there are two futures in this future wait function being passed right here. And if you say final foo, you can see the result of this guy is actually a future of a list of iterable persons. So it's kind of interesting. Let's wait here and think a little bit about this. What does this even mean? It's like 3 sandwiches. It's first sandwich is an iterable of person. Okay, let's talk about that first sandwich. What does it even mean? An iterable person. That means just a list of person. Okay, iterable is kind of like a lazy version of list. It's more performant. Okay, so that's the list of persons, because every single one of these guys actually returns an iterable person. Okay, so read this first part of iterable person as that's the result of any of these futures inside this array. Okay, so that's the first thing. Every one of those APIs returns an iterable of person. Okay, however, that list itself, that iterable, the result of any of those APIs is inside a list. What does that mean? Well, it simply means that there are more than one APIs happening at the moment. That's why it's a list. The first one returns an iterable. The second one returns an iterable of person. And these two together, the iterable of iterable person together are inside a list. That just makes sense. One API returns a list. Second API returns a list. Both these lists go into another list. So that's the result. That's the second sandwich. And the third sandwich is the future itself, meaning that the work isn't performed yet until you await on it. It's a package. So it's a package of a list of people, simply because there are two APIs in here. Okay. How do we unwrap the package? Using the await syntax. So if you do that, you remove then one of those outer sandwiches. Now it's a list of people. Okay. So that's how you await on a future wait. Okay. So let's go ahead in here and we say final persons is that, and then we say persons log. Okay, just like that. And we remove the code that we had from before. So let's go ahead and I'm going to bring up the console in here. I'm going to hot restart the application. And now you can see what we're seeing in here is the first person with foo1, person with bar1. So that's the first API. Then the second API also went with that grabbed foo2 and bar2. So we were actually able to execute our futures simultaneously and conclude and wrap the results into one package and bring it back. So that's how you would package up multiple futures using future wait. Okay. All right. But in realistic cases where you, for instance, have a custom backend that you've written, for instance, with Django, or you've created with Node Express, for instance, together, what would happen if one of these APIs actually failed? Let's say you're making 3 API calls and they kind of need to be inside a transaction, meaning that all 3 either have to succeed or the entire thing fails. That's like the definition of a transaction in SQL world, at least. So how do you handle that? How do you handle the case where one of these API fails, but the other one succeeds, or one of them succeeds and everything else fails? Well, we're going to talk about that now. So let's change the URL of one of those JSONs to an invalid one, as I mentioned in the caption at the bottom of the screen. Let's go ahead in here and say, instead of people1, we're going to say people11.json, okay? And then I'm going to save this file and actually do a hot restart. As you can see in here, we're getting an exception. It's a Dart unhandled exception in here. And it says format exception, unexpected character at character 1. What does that even mean? Well, if you open this URL manually in here, you'll see that it says cannot, actually you can't see my screen right now. I'll bring it up. It's a Safari window. It says cannot get API. So that's the return, like what the web server, the live extension server is actually returning. It says cannot get API. And this is not a valid JSON. That's why this whole thing is falling apart right here, saying unhandled exception. And it says, yeah, it's I can't read this as a JSON. So how do we handle this case? How do we add some error handling to our code? Well, error handling can either be done at an individual API level, or you can actually do an API error handling on the entire package. So as we saw before, every one of these parse JSON functions returns a future. It's a package. So you can either add error handling to every single one of these, or you could add error handling to the entire package. Because remember, this future wait is in its own a future. It's a future of the collection of these futures. So every future you can do error handling on, okay? So let's add error handling on this entire package And you do that using a function called catch error. Okay, and you can see this catch error. Let me see if I can resize this somehow. I can't. And it says a function on error. Okay, so this on error is a function that gives you the error and the backtrace. If you go to catch error and look at this function in here, let's see if it has some documentation in here. You can see it says it's a dynamic and a stack trace. I said backtrace, but what I meant is a stack trace. So what we're going to do in here is say we don't care about that dynamic value and we don't care about the stack trace. We're just going to name them as underscore and underscore underscore, like here. So after doing that, what you need to do in here, you actually have to return something from this. You're saying that I'm catching all the incoming errors and I actually have to return a list of iterable of person. Okay, so then you say, okay, I'm going to say in case of any error, I'm going to return a list of iterable of person, and I'm going to make sure it's empty. Okay, so that's your error handling at the moment. So I'm just going to press save and do a hot restart. And now if I run the application, you can see we're getting an empty array. So just keep in mind that catch error is a function implemented on any feature that allows you to handle errors. It allows you to handle error for individual features. That means that you could actually remove this and have catch error in here as well. So you could say, I ignore the errors, and in here, I instead return an iterable person, empty. You could have done that as well, and this is a constant, okay? So you can have catch error for individual features, and you can have catch error for your entire feature. Any feature can have catch error. So since this is quite a handy function, I mean, it is a function that it is intercepting a list of iterable of anything and returning an empty list for it. We can actually make this into its own extension. So we can then reuse this functionality on any other feature that returns a list of iterable of anything. So what I'm going to do is I'm going to add an extension to our function. So let's go ahead, to our application in here. And I'm just going to paste that here. I'm going to show you how it works. So we have an extension. It has a name, empty on error. And it says I take an element, I return an element. And this extension is on any feature whose elements are of type list iterable of that object. Okay, so read this as, for instance, person, and then put person in here as well. Okay, so just anytime you see this E in your head, replace it with a concrete type. It makes generics a little bit easier to understand. And then here you're saying that, okay, in my extension, I have a function called empty on error that returns a feature of a list of iterable of person, for instance. And what it does is it only calls the catch error function on itself, just like we're doing down here. You see, it's the exact same function implementation, okay? And the only thing different in this extension is that it's using generics. That's all. So instead of having a concrete dependency on person, it's saying, I don't have dependency on any object at all. I only use generics, okay? So having that in our application as an extension, we can remove this catch error in here and instead just say empty on error and save this file. And I'm just going to do a hot restart, and you see the result is exactly the same. So I want you to pause this video and just have a quick look at this function again, because I think it's quite important. I use something like this quite extensively in my own applications. So I think it's very important that you understand this function and hopefully be able to use it also in your applications as well. So that was just quickly about error handling on features. Let's go ahead and commit this code. And I'm going to just say in here, git status, git add all, git commit step 2, and git tag step 2 as well. So now we've tagged our code successfully, and we've also committed it successfully. The error handling that we've added to our application at the moment works kind of, and that's I'm saying kind of simply because if any of the features inside future wait fail, the entire list, the entire future wait will fail. Let's have a look at the code one more time in here. So here, future wait is waiting for 2 specific features here, both of which are returning an iterable of person. Imagine the first one fails and the second one succeeds. The current implementation that we've added empty on error at the end of the entire future ensures that the entire future will return an empty list should any of the futures inside future wait fail. However, sometimes you may not want to do that. And what you probably instead want to do is to say, if any of these futures inside future wait fail, that future particularly needs to return an empty list. And that's exactly what we're going to do right now and fix that. So when we looked at it, people one URL, if you look at the URL, we messed it up here intentionally. So it says people 11 JSON. If you bring our application up, you can see that the entire result is now an empty list simply because just one of these features failed. So if you put more features in here, it doesn't matter. The entire feature will fail and the entire feature will return an empty list. So let's go ahead and fix this and instead have the ability to basically drill down and say, if any of these features fail, that particular feature has to return an empty list. And the other features in the list of future wait should go on about doing their jobs and return their own results. So we need error handling per future. What we can do is to write an extension function that can handle errors per future instead of basically handling the entire future's error. So we're going to go ahead and create another extension in here. I'll paste it right here and I'll explain how it works. So what we're going to do is saying that any feature that returns an iterable of anything can have a new extension that we call empty on error on future. And what this guy does then it says, okay, I know that this feature returns an iterable of elements. Then my function also returns a feature of iterable elements, meaning that the result of this is also the same result as the future would otherwise have should it succeed. However, we do a catch error in here, and then we ignore the error and we ignore the stack trace. And instead we say we return an empty iterable in here. So if you look at the implementation and the difference between this implementation and the previous one, the difference is that this implementation that we added here, empty on error, and that function itself was implemented on any feature that returned a list of iterables, meaning that the result of this future wait. However, now we're implementing this empty on error on any feature that itself returns an iterable of E, meaning these features inside. So again, you need to have to think about this in terms of pipes. The future wait in here, which is persons, returns a list of iterable of persons because there are various or two futures in it, each of which returns an iterable of person. So the result will be a list of iterable person. You could go ahead and flatten this with flat map or something and flatten the entire list so that the entire thing will be an iterable of person. You could definitely go ahead and do that, but the way it's handled by default, it's that it's a list of iterable of person. So that was our first extension. However, now we want to be able to handle errors per feature in here, and each of these features, you can see it returns an iterable of person. That's why our new extension works on futurable of iterable of person, for instance, or element. And its implementation is almost identical to the previous implementation. The only difference is that in this new implementation, we only return an iterable of that element empty. But in the previous one, since the element was actually wrapped inside an iterable and that was wrapped inside a list, then we have to create this kind of syntax, a list of iterable of E empty. Okay. And again, I mean, I feel comfortable with generics, but I completely understand that a lot of people may not be comfortable with generics. And the thing that helps a lot is to completely forget these E things in here and instead go ahead in your head and convert all of this to concrete types. So then it will make a lot more sense. You can see in here. So we're saying we return a future of iterable of person if that future fails. And here we return an empty iterable of that person. So just don't think so much about the generic types, to be honest with you. Okay. So let's go ahead and put this to use. So instead of doing this, what we're doing at the moment, we're going to remove this empty on error on the entire future. And instead, we're going to have empty on error on every future itself. And remember, these two empty on errors, they're different. Like if I put the empty on error back where it was here, And if I command click on it on Mac or control click on Linux and Windows, you'll end up on this first extension that we wrote. However, if you put this empty on error per future, you will end up in the second implementation. You see, because we've constrained our extension to any future whose return value is an iterable of some sort of an element. So there are two completely different extensions with the same name. The function name is the same, but remember in Dart, you have to have unique extension names. So that's why the second extension that we wrote has a different name from the first one, because they can't have the same name. So then you'll get an error. Just know that though the functions are called the same, there are two different, completely different functions, okay? So what we expect to see from here is for the parse JSON, the first parse JSON to fail, and hence go into the empty on error, which does a catch error, and that guy is going to say, okay, I handled the error by returning an empty iterable. The second one is going to say, well, no error happened. I'm just going to return the array of persons that I read from the JSON. I'm just going to return it, meaning that future wait is going to be a list of iterable of person whose first element is an empty iterable and the second element is the actual result of the second parse JSON. Okay, so I'm going to do a hot restart in here and have a look at the result. You can see the first element of this entire list is empty, is an empty iterable, meaning that the first parse JSON failed and the catch error kicked in and did the empty on error. So it returned an empty iterable. However, the second one returned, actually could download and parse the JSON successfully and returned that JSON to us. So this is basically an example of how you could potentially go about handling errors per future rather than handling them for the entire future. And I mean, this is really just like a playground. It's completely up to you how you want to handle these errors and futures. But remember one thing, that futures can't have errors. Those errors have to be handled. You can't expect a list of futures to be called inside your future wait and one of them fail and just all of the other ones to go ahead with their normal life, assuming nothing has happened. If any of the futures inside future wait fails, the entire future will fail unless you actually catch those errors or catch that particular error and return a response or another future. So that's very important to understand. It's the same thing if you're doing reactive programming, for instance, with RX. The language, I mean, the language that these protocols talk to each other is very similar. In RX, you can't throw an error inside a flat map either. You have to handle that, okay? So it's the same thing here with futures in Dart. So let's go ahead and commit our code. I'm going to go here and let's just say git add all, and let's say git commit step 3 in here, and then git tag step 3. Okay, fantastic. So that was step 3 of this chapter. Now that we're done with this example, it's time to go ahead and have a look at another example, another functionality of future in Dart. There's a really useful function on future class called forEach. And forEach allows you to do work by completely ignoring the result of your futures. So let's have a look at an example on why forEach could actually be useful in some cases. So if you're performing operations in a row where you actually don't care about the results, let's say that you're performing some fire and forget kind of API calls to your server and saying, okay, when an application is about to terminate, I'm just going to make 2-3 API calls and just completely forget about the results. I don't actually care because, well, you can't care. Your application is dying kind of, so, or it's being terminated. So it's really useful in the case where you just want to perform some work asynchronously and you don't care about the result, or you can't care about the result. So what we're going to do in here is to change the function inside our tested function, or the functionality inside tested function in here, and start using future for each. So I'm going to get rid of all of this right now. And let's just go ahead and say final result is equal to future for each in here. And if you go to the code for each, you can see that it says you need to give me an iterable of something. And then you have to go in the second parameter of this function and return a future or an action that takes that element and does something with it. So let's go ahead and actually give it an iterable. So what we're going to do in here is to say, okay, for the iterable, we're actually going to generate the URLs of these people, people1 and people2. Okay, so let's say iterable, and we're going to do a generate, and we're going to generate 2 values in our iterable because we have 2 URLs to hit. And that iterable generate will generate the values of 0 and 1 in this case. And that value is passed to the second parameter to iterable generate. And for that, we're going to actually generate the URL, which is people1 and people2. So let's go in here. So we're going to say people $i+1, basically meaning that in the first generation of that iterable, I will be 0, meaning that in here we'll say 0 plus 1. It'll be people1.json. And the second iteration, it will be, well, I will be 1, and 1 plus 1 will be 2, meaning people2.json. So this is really just our iterable, okay? Now that we're doing that, what we're going to do then, as you can see in here, we have this little element, the little function that we have in here, and this really just needs to return a future. So what we can do in here, let's just say parse JSON like this. Okay. And you can see what's happening here. It's really just, we're saying for this iterable, every time that iterable returns a result, just make this function call. All right. And the reason this function is really passing, just like fitting into this function call, you'd be like, yeah, but you're not passing any type of URL to it. What's happening in here? Again, if you look at the signature of future wait, you'll see that anything that you return from this iterable will in turn be passed into this action that you provide in here. You can see the data types are exactly the same. T comes out of the iterable, and then T will be passed into this action. That's why we can pass in parse JSON as the second parameter of this for each, meaning that every URL that is coming out of this iterable is being internally passed into the parse JSON function without us having to do anything, okay? So then what we also want to do is somehow basically be able to understand whether an error happens in this scenario or not. Does any error happen in our code, and how do we handle that error? So as I mentioned, if you look at the return value of this for each, is just a future dynamic. And if you look at the documentation for each, it tells you that returns a future that completes with null when all elements have been processed. So if any of those futures basically fail, how are you going to handle that failure then? So knowing that a successful case will return null. So if all these futures that you're passing to future for each successfully complete, the result of future for each will be null. So then you can take advantage of that and add a catch error to the entire future for each and return a non-null value should anything happen. So let's go ahead in here and say catch error. We completely ignore the incoming error and the stack trace, and then instead we just return -1. Okay. In here, you can see in here what we're saying is that we know that you return null should anything happen, but sorry, you return null should nothing happen and everything is successful, but we are returning -1 if anything does happen, if any error does happen. So then this gives you the opportunity to understand whether something did happen inside the future for each. So let's go ahead and say if result is not null, and in here we could just say print, and we also have to await on this. So then we say print, or we say error occurred like this, and then we log this to the screen. Okay. So let's save this, and I'm going to do a hot restart. And here's our debug console, and here's our output. And let's see the tested function. All right, so the tested function at the moment is not returning anything. It's not printing anything to the screen, simply because both those operations are successful, meaning that since these two URLs are valid and live server is serving them correctly, nothing is happening. Therefore, the result is null. Therefore, our log is not being printed. However, if we happen to mess this up and instead said take the index as it is, meaning that people 0.json, people 1.json, the people 0.json is going to fail, meaning that we're going to go into the catch error and return -1, which will then result in result not being null and our string to be logged to the console. So I'm just going to do a hot reload. And now we should be able to have a look at our debug console in here. You can see it says error occurred. Okay. But if we fix that URL, go back to how we had it before, hot reload, then nothing is happening to the screen. So this is really useful if you're performing a transaction, if you're performing like multiple calls to your backend, kind of like in a fire and forget fashion. So you don't really maybe care about the ordering, you don't care so much about the errors, you just want to say, yeah, just do it. And then if something happens, I may just like mark this whole transaction as fail or something like that. So, but remember, the result of Future.forEach is also a future that returns null. That being a future gives you the ability to chain it to other futures using then, for instance, to do error handling, to do retries, everything. So the result is a future, just remember that, but it is a little bit less sophisticated than future wait that we've seen before, in that it doesn't actually give you the results back. So it just gives you null, all right? So between choosing future wait and Future.forEach, if you're not sure which one to choose, future wait should be used if you want the results of your futures. Future.forEach should be used if you don't care about the results of your futures, you just want to fire them away and forget. Okay, so let's go ahead and commit this code as well. So I'm going to go to the terminal here and let's just say git add all, git commit step 4, and then git tag step 4. So that was the 4th example that we did in this chapter. Now that we've talked about how catch error works and also how we can use future wait and a Future.forEach, I think it's good time that we start to talk about streams as well. Up until this point, we've been talking about futures, and futures are great because they perform asynchronous tasks that will be performed in the future and return the result to you as their name indicates. However, there's also the concept of streams in Dart, and many other programming languages also have this stream support, but perhaps using other names. If you're familiar with reactive programming and RX, then you probably know streams as observables. And streams in Dart are very powerful tools that you can also take advantage of, but they take concurrent programming to a new level. And I understand a lot of developers are struggling with understanding all these different terms in Dart. So I hope in this chapter I can clear some of those misunderstandings up. So let's talk about asynchronous generators first. So what asynchronous generators in Dart are is that they return a stream. Let's say that you have 10 API calls. At the moment, we have people 1 and people 2. And what we've seen is that we can gather those APIs inside, for instance, with future wait, and then gather those 10 API calls, for instance, and then we get a future of a list of iterable of person. Another way of saying the same thing is that if you have 10 pipes, each of which performs, for instance, an API call. So here's pipe 1, here's pipe 2, 3, 4, 5, 6, 7, 8, 9, 10. What you could do is to create a function, an asynchronous generator that iterates from the value 1 to 10, converts that value to the URL of every one of these futures or JSONs, calls the parse JSON function, and then returns that result that comes from the parse JSON function inside a stream. So a stream is also like a pipe. So what is the difference? The difference is that a stream is a continuous pipe of information, whereas future is just one pipe that starts at a point. It either produces a value or produces an error, and then it completes. For those of you who are familiar with reactive programming with RX, you would probably know futures as single. Single is usually the definition of reactive programmers' RX definition of future. Whereas a stream is an observable, meaning that a stream can produce more than one value. It doesn't necessarily even have to produce any values. It can start and it can stop. It can start and it can fail. It can start and produce one value and then fail and stop. It can start, produce multiple values and don't fail and complete. So a stream's lifetime, really, I mean, if I put it to words in, or put it inside some sort of a documentation, is that if this pipe is the beginning of that stream, and this is the lifetime of that stream, it can produce a value, for instance, then it can continue, produce another value, and then continue for some time, and then it ends. Or it can start, not produce any values, and then it can end. Or it can start and then work and then error and then end. Or it can alternatively start, produce a value here, wait, error out, and then end. So it's really like it's a pipe that is continuous. So it has always a start and an end. It optionally also has values, or at the end, it could have an error. So it's the start and stop that are certain about a stream. However, any element production or any error production are not certain inside a stream. But there are some rules. After a stream produces an error, it cannot continue. It will have to be caught. That error will have to be caught, and perhaps a new stream has to be spawned. And if the stream produces any errors, any elements, it doesn't necessarily mean that it will not produce any errors. So the production of elements and errors inside a stream are optional. Start and stop are always certain about a stream. Even though, I mean, stop, in some cases, you may say, well, the stream will stop as my application stops. That's also the case. However, in reality, streams always stop at the end when they die. So let's go back to asynchronous generators and kind of have a look at how they work. And an async generator, what it does is, if you go back to this these diagrams that I created, an asynchronous generator allows you to create a stream inside a function, and it will allow you to return values and inject elements into the stream, into this return stream, by using a keyword called yield. Yield does not return from the function. Yield will only produce values that will then be inserted into this return stream. So we're going to go and have a look at an example soon. So they're useful for performing a series of operations. So as you'll soon see, we're going to go and create an iterable and create these URLs, and one by one we're going to call these URLs and then produce the results and return them into some sort of a stream. So asynchronous generators are one of my absolute favorite features inside Dart, because they're not available in so many other languages. So let's go ahead in here and start using asynchronous generators. So what we're going to do in here, we're going to produce a function that returns an iterable of a person in here. Okay. And please have a look at this function signature again. We're going to call it get persons actually, and finish the function signature first. Then I'm going to explain how it's actually working. So what this stream return value is saying is that I'm a pipe, and every time a value is produced in this pipe, that value should be an iterable of person. Had you said that I'm a pipe here, and every time I produce a value, I produce a person, that means that your pipe here starts, it continues, produces a person, it continues, produces a person, continues, and perhaps dies here or ends here. However, what we've written in here saying that the stream of iterable person, saying every time I produce a value, it will be a P1, P2, and etc. And then again, P, for instance, 4, P5, etc. So every element of this stream will then be an iterable of person. So that's like the difference of how you actually define your stream. And basically by putting any value in front of the stream's definition here, you're saying that every element of the stream is of this type. Every time the stream produces an element, a value, that value is of this type. Okay, so it's really just the definition of how you define your function. When you then mark a function with async asterisk in front of it, what it means really is that this function is an asynchronous generator. And there is a similar function, there's a similar syntax for synchronous generators, and you just type sync asterisk, which is a completely different thing in Dart. But in this case, what we're doing is saying that we're defining a function which is an asynchronous generator, and in here we'll then have the possibility of using a keyword called yield, as you'll soon see how we're actually going to use it. So let's go in here and actually create an iterable that produces our URLs. So we have something in here, iterable generate. So I'm going to just steal that function from here. Okay, so iterable generate. And let's go ahead in our new function. We're going to say for final URL in this iterable. So now we have our URL. And for every one of these URLs, what we're going to do is we're going to call our get JSON function. So let's have, parse JSON. So parse JSON takes URL and returns an iterable of person to us. So let's go ahead in here and say final foo is await parse JSON, and we pass the URL to it. So what is this foo now? You see, foo is an iterable of person. So now that we're waiting on that, how can we actually, every time that parse JSON is done, how can we return its value in the stream? Well, you do that using the yield keyword. So you could just say yield foo, and you can see then Dart is completely happy about this, saying that, okay, every time I get a value from this iterable, the first time it's the iterable generates 0. 0 comes in here, plus is 1 becomes 1. The return of this iterable generate will then be a string. As you can see, it's actually denoted here because we're returning string from this function. The string will be passed in here. We're awaiting on the result of parse JSON. We can await because we've marked our function as an asynchronous generator, and the result of parse JSON in turn is iterable of person, and then we're inserting that iterable of person in the return stream. So that's the beauty of async generators, that you don't have to actually manage a stream controller at all. For those of you who are comfortable with, or familiar at least with, stream controllers in Dart. So that's how you create an asynchronous generator in Dart. So you're literally inserting values in the final stream. And when your function is done, that stream will then be closed, and you can't insert more values into it. So what we could do is to make this code a little bit shorter, remove foo, and just directly yield this value. All right. So what we can do now that we have the stream, how do we actually consume it? So if we go back to our tested function, let's remove the functionality that we've written before. Now, we somehow have to consume this stream. And if we went in here and say final foo is await get persons, okay, we can now see foo is still a stream of iterable person. So just by awaiting on a stream, you're not really unpacking its results. So await in Dart is should be applied to futures. However, you can see we're getting a warning here from our analyzer saying that you're applying this to a stream, which is not a future. And so you need to understand that the await keyword should only be prefixed on futures when you're trying to unwrap them. So then the question is, how do you go ahead and unwrap the values inside a stream? And the result and the answer to that is using the await for syntax in Dart. So we say await for final persons in get persons. So now you can see persons. Yeah. Now you can see persons is iterable of person. So if you have a stream, then you have to use the await for functionality in order to read the results of that stream. And then we can say in here, persons log, just like that. And if I do a hot restart and bring our log up, you can see that the first feature inside that stream succeeded and return the first JSON's results parsed as person objects. And then the second one also did the same thing and returned the second, the contents of the second JSON parsed as person objects. Okay, so let's just have a look at this. The result of asynchronous generators has to be a stream. So you cannot mark a function as async asterisk without that function actually returning a stream. And that's really just how it works in Dart. So if you mark a function as async asterisk dot Dart just completely understands that this needs to be an asynchronous generator and its return has to be a stream. So if you just say void in here, you can see an error. Functions marked async must have a return type that is a super type of stream. So that's just how it works, and that's how you can control your streams with asynchronous generators. So let's go ahead then and commit and tag our code like we usually do. So I'm just going to go to the terminal here and let's say git add all and git commit. And let's just say step 5 in here. And then we say git tag step 5 as well. So that was the 5th example of our chapter. So we can say that up to this point, we've seen how we can execute a list of futures using future wait, and also how we can go through a list of futures and execute them with Future.forEach. And I've also shown you here how we can use asynchronous generators in Dart to create streams. Now, what we're going to look at in this part of the chapter is dependency of futures on each other, so that you can also get an idea of how, for instance, you can make an API call, and dependent on that API call, on that API call's result, then you can issue other API calls. So that's what we're going to have a look at in this section of this chapter. So there's already functionality for this available in Dart's asynchronous programming paradigm. So I'm going to demonstrate that for you in this chapter. So what we're going to do is to define a list of APIs. At the moment, if you look at our source code, we are hard coding kind of these URLs. But what we're going to do in this section of the chapter is to go ahead and create another JSON file in which that JSON defines our endpoints for us. So we will just hard code one endpoint, and that endpoint can then itself contain a list of other endpoints that our application is going to invoke. Okay. So what we're going to do in here is to go and define an API's JSON file in here. Let's go and say in APIs JSON. Okay. And I'm going to copy paste the contents of that file in here so I don't have to type it again. So API people1 and people2. So you can see that this API's JSON file contains the endpoints that we're going to call. And to be honest with you, this is only for the purpose of demonstration, so that we are going to first make this API call and get its contents. And then for every content, every string that's available in there, we're going to make another API call to actually grab instances of the person class from that endpoint. Okay. So what we're going to do in here is just going to go to our main Dart file and remove almost every code that we've written except for the person class. So let's remove that. And perhaps we're going to keep the parsing of the person in there. So it will be good if you just kept the parse JSON, and let's just remove the people1. And perhaps we are going to have the tested function actually left as well here. So test it, and we're going to keep it async. Okay, so parse JSON is going to be left there, and also the person class is going to be left inside our code. So what we're going to do now is to actually take this to the next level, and instead of just having like this type of parse JSON, we're going to define a little mixin, and this mixin is going to allow us to make any API call with any URL and grab its results as an iterable of anything. So in some cases, it will be an iterable of string. So for instance, in the case of our API's JSON, the result of this thing is an iterable of string. In the case of our people1 and people2, it's an iterable of a map of string and dynamic. So we need to write a mixin that can do that work for us. So it can hit an API, a URL, and parse its contents as a list of something and come back to us basically as a JSON. We have that code kind of already. It's called Parse JSON in here, but let's go ahead and create a mixin in here. And we're going to call it list of things API. And it's a generic mixin, okay? And what we're going to do in here is to kind of take this code that we've written in here and just say that we have a function in this mixin that returns a future of iterable of that thing in this mixin. And we start off by kind of like creating our get call in here. So we're going to go ahead and create our HTTP client as we have here. So I'm literally just going to copy and paste this code in here. And let's call it get string URL and like this, okay? So here we're taking a list of dynamic, but in here we don't actually parse the JSON. So in here we just say list, and then we cast the list. So we just say list.cast, just like that. So here's now a mixin that allows us to have a functionality of getting the contents of a URL that contains a JSON whose contents is a list of something, and that something is denoted by this T in here, okay? Then what we're going to do is to actually use this mixin inside a class that can retrieve the contents of this API's JSON for us. And this is this URL. It basically will give us a JSON that is a list or iterable of string. So let's go ahead and define that API in here. I've already written that, so I'm just going to copy paste it in here. Okay, and I'm going to remove this code. So if you look at the definition of this API, it's very simple. It's a simple class that only implements the list of things API mixin, and it says that the contents that it receives is a string, meaning that now this class all of a sudden has a function called get that retrieves an iterable of string. So this way, I mean, this is one of my favorite ways of creating custom APIs with Dart and Flutter, of course. Okay, now that we have that, we also want to define a class. So this gets us, you see, it's a get API endpoints, but we also want to have an API for every, like the person API that can take a URL, for instance, people1.json, and it should be able to return a list of person classes. However, our person classes have this from JSON functionality in here that is not something that this code can actually handle. So it can't create concrete instances of any other class for us. It can only grab us the list of map string dynamic. So what we need to do is to go ahead and create this little class in here, list of things. So we're going to say class get people with list of things API, and we know that the list of things that this retrieves is a map of string and dynamic, right? So let's go ahead and do that. Now that we've done that, if we, for instance, say void blah, now we have a function called get, and this get is coming from this mixin, and this get will return actually our iterable of map of string. So what we could do is to create a function in here and say future of iterable of person. Okay, so now we actually add some extra functionality to our class that can not only get the map of string and dynamic, but it can also parse it into instances of person and return that. So what we're going to do is to say get people, okay, and a string of URL. Then what we're going to do in here, we're going to say get that URL. And then when you get the JSON, then we're going to say JSON.map in here. And I'm going to call, actually, this is JSONs, and then JSON map person dot from JSON, like that. Okay, so that's our implementation of this function. So have a look at it. So now get people has this extra function called get people, which uses the get function defined inside the list of things API mixin. Fantastic. Let's go and put this to test. So what we're going to do is to grab this. Let's have a look in here. First, we want to get the actual API that returns the list of URLs that we have. So what we're going to do in here is to say await get API endpoints, and that has a get function with a URL. So I'm going to just copy and paste this URL in here. That's the URL. Okay. So this gets us the list of strings. Okay. Then what we're going to do is to we go in here and then we add another then in here. And we know that these are URLs. If you hover over them, this is an iterable of strings. So these are the URLs that we actually have to call. Now, for every one of these URLs, we are going to create a future that grabs every. So we're going to create a future that uses this get people API. So let's go in here and say, for every one of these, we want to create for all of these URLs, we want to create a future wait, as you remember from the previous sections of this chapter, that we can in here then create a list of futures. So we say we map these URLs to, if I say URL in here, URL, to that get people class. So every URL is going to become a get people class, and then we're going to call get people on it with that URL. Okay. So now that we're awaiting on it, let's do some cleanup in here, put some commas so the code becomes a little bit cleaner. And then we're going to say final people is await. Okay. And if I move my mouse over this, you can see it's now a list of iterable of person, exactly as you would expect from future wait. So I actually suggest that you pause this video right here and have a look at how this code is structured. So you can see we're first making this an instance of this class. We're calling its get function. This is coming from our mixin. And since this class is using the mixin and it's making its concrete type saying that it is a string, you see it returns an iterable of string, then this result is an iterable of string, this URLs, you see. Then in there, we're saying future wait, and for every URL, we're creating an instance of get people class, and we're calling it get people function, which returns a future. And these futures are then being gathered inside future wait, which we already know returns and a list of the results of those futures, and those results are iterable of person. So it will be a list of iterable of person, and that's what is coming into the people variable here. So what we need to do then is to go ahead and then say people.log in here. Okay, so I'm gonna save this, and just for the sake of being sure, I'm gonna also hot restart the application. So let's do that, and I'm gonna hot restart the application. Actually here, we're getting some error in here on handle exception, format exception, unexpected character. And that's simply because we've messed up something. APIs, it should be API. So I'm gonna do a hot restart, and then we can see the results printed here. So so you're seeing here the result of chaining APIs. First, this API is being fired, and then depending on its result, we're actually chaining it to multiple other futures, each of which is an API of its own. Excuse me. So what is the difference between async and async with an asterisk, really? Well, as we've talked about it, async marks a function as being able to use the await keyword inside the function. So it's really like a tooltip. It's just a tip to the compiler saying that I want to be able to use the await keyword in this function. That in turn indicates that this function perhaps is doing something that returns in the future it's doing some asynchronous functions. It's executing some asynchronous functions, but it doesn't necessarily have to do that. You can, for instance, go ahead and create a function in here that says void gets data and mark it as async, and don't write anything in it. It's not returning anything. It's not making any API calls. Remember, all async does is it gives your function the ability to make asynchronous execution available. It makes it ready for you to use the await keyword inside this function. Whereas if a function is marked as async with an asterisk, that literally says to the compiler that this is an asynchronous generator. Its result should be a stream of something. And in that function, you can insert data into the returning stream using the yield keyword. So that's the difference between the two. Okay, let's go ahead and commit our code now. So I'm going to bring up the terminal here. Let's go ahead and say git add all, and then git commit step 6. And I think it was step 6, and then git tag step 6 as well. So that was for the 6th example of this chapter. Well, after we are done with this particular example as well, since we talked again about futures, let's go to talking a little bit more about streams. We touched upon streams by talking about asynchronous generators, but we didn't really go deep into how streams actually work and what the stream language actually is in Dart. So what I'd like to think about in terms of streams is really think of them as pipes again. And if you think, I mean, if I can draw here just a simple language of like futures and streams, have a look here. To me, a future starts. So this is the start point. It goes on and it produces a value and then it finishes. That's how usually futures are. So if you say a future. However, a future could also be that it produces an error. So it either produces a value, let's say V, or an error. And then it finishes. However, a stream is more like this. It's a stream that it starts here and then does some work, and then it produces a value. Then it could continue and produce another value, and perhaps at the end error out and then finish. Or it could alternatively be value, and then just complete. Or it could also be it goes on and it errors out and completes. So it's any combination of start, stop plus values, optionally ending with an error or a normal stop. Okay. If you're familiar with reactive programming and RX, for instance, RX Swift or RX Job or RX Dark, you're probably comfortable with also, for instance, observables. And streams are pretty much just like observables. So their language is a little bit different. And by that, I mean like their functions are different. Whereas in reactive programming with RX, you'd use, for instance, flat map latest. In the world of Dart and using streams, you'd probably use async expand. So the functionality is there. However, it's under different function names. At least most of the functionality is there. Okay. So streams allow asynchronous expansions. And what this really means is that every stream value that is produced inside that stream can birth another stream. So again, if you think of a stream as a pipe, what you could say, I mean, I like to, whenever I'm teaching like streams to someone, I usually use branches in GitHub to explain, or sorry, in Git to explain that. So let's say you have a branch in Git and then you are making some commits. That branch is your stream. From any commit, you can make another branch. And from that branch, you can keep making commits. And then you can do the same thing on the other branch. You can take a commit from that branch and merge it back into your normal branch, the main branch, for instance, or you could branch off again from there and make another branch. So these branches are no different from streams in Dart or any other programming language that supports streams or observables for that matter. So it really helps to think of streams as kind of like a pipe or a branch in Git. And a lot of you programmers out there are familiar already with Git, so you know how branches work. So if it helps you to think in terms of Git, go for it. Otherwise, you can also think in terms of, for instance, pipes of water, for instance. So what we're going to do in here is to have a look at an example of this tested function that we have. So let me remove this code in here. So what we're going to do in here is also remove this a little bit. Let's go ahead and create a stream that starts periodic here. And we say const duration seconds 1. Okay. Or seconds 3, let's say. So now we have a periodic stream, as you can see in here, that produces a value every time, every 3 seconds. So what you could do is to say await for final value in that stream, and then you just say value log. Okay, let's go ahead and have a look at what this value is actually going to be. So let's have a look. Let's do a hot restarting here. And you'll see on handle no such method error. The method log was called on null. And that is simply because this stream is not producing any values really. Okay, because we've forgotten to actually give it some data to produce. You could optionally go in here and say, for instance, something, and you could say hello. And then this value of hello would be produced every 3 seconds. So you will see in here now the value of hello is being produced, okay? But what we want to do in this example is to completely ignore the value of our stream, but every time it produces that null value every 3 seconds, as we saw by removing this, it produces a null value. Let's see what there is, seconds const duration. Okay. What we're going to do then is to use a function on stream called async expand. And I'll put it here. Let's see, async expand. Okay, let me just bring this down a little bit so we see how it works. So what async expand does really is says, for every time this stream produces a value, create another stream. That's really it. That's really all it does. It just says, every time I'm making a commit on this branch of my code in Git, take that commit and go to another branch and do whatever you want with it. Okay. And if you look at the async expand function in here, you need to actually in what the value you provide to this async expand, that itself has to be a stream. So literally every time the stream produces a value, it allows you to go and branch off into another branch and just keep doing whatever you want to do in there. Okay. For those of you who are familiar with reactive programming with RX, this is similar to flat map. And I don't think it is actually flat map latest. It should be flat map because it allows the previous subscriptions to live on. So again, if this is very strange to you, if you believe, I don't really get this, I completely understand. For me, it took a while, like when I was learning reactive programming with RX, about 2 weeks I had about 2 weeks I had headache because everything in my body was telling me that this is wrong. But that was literally me being scared of it. And I think you need to pause this video perhaps if you're not understanding the concept, just to think about branches and Gits again, how that could also become very complicated. Like you have a branch, you make commits, someone takes that, one of your commits make another branch, and from that branch, someone makes a future branch, and then things get merged. You're already doing this. If you're a software developer, you're already familiar with reactive programming and with asynchronous programming for that matter, because you're already working with it in Git. So don't be afraid. This is nothing different than putting those concepts of Git into your code. So every time someone makes a commit, every time the stream sends a null, we're making a new branch. In this branch, we're going to ignore this incoming value because this is null. And what we're going to do is to actually go to that get people, and we're going to say call the get people function. The URL, I'm going to copy and bring it here. We have a certain URL in here. Let's say people1 API. Okay. And let's bring this down a little bit so it's a little bit cleaner and easier to understand. But what you also need to know is that the result of this async expand function can't be a future. This get people is a future, but we can't return that. We actually have to make that a stream. So let's say as a stream, just like that. All right, so that to me looks fine. Let's see what we're actually dealing with here. Get people in here as a stream. That looks fine. I think we're just missing a parenthesis. Perfect. So let's put it in here and then just say people log and then in here we just say people log. Okay. Great. Let's see this in action. I'm gonna save and actually gonna I'm gonna hot restart the application, and let's see. So 3 seconds passed, we made an API call. Another 3 seconds passed, we made another API call. You can see 3 times here, 4 times, and then the 5th time. So this is really, I mean, I don't expect everyone to understand this immediately if you haven't worked with streams before, but this is, I'm just trying to demonstrate to you that, hey, you can make an API call, you can make a future call, such as our get people. However, you can turn it into a stream, and you can then take advantage of async expand in your normal stream, for instance, to actually make an asynchronous API call on an asynchronous stream, okay? So that example is also done. Let's go ahead and commit our code in here. Let's see. I'm going to go here into the terminal and then git add all. Let's say git commit step 7 and git tag also as step 7. So that concludes the 7th example in this chapter. So after this example, what we need to have a look at is a little bit more advanced topic, which is stream transformations, something that I don't think many people actually talk about. And I thought in this chapter, it'd be really good if we could have a quick look at stream transformations. At the same time, I'm also updating some scripts here and see how you can use them in your application to increase reusability of your stream transformation. So what stream transformation really is if you're already familiar with reactive programming with RX, is a way to, as its name indicates, transform values of your stream to other values. You could, for instance, say every time my stream of integers produces an integer, I want to convert that integer and I want to convert it to a string. Or I want to, for instance, I have a stream of names, and for every name, I want to transform that name then to a value that comes from another API. So that's transformation. If you're familiar with reactive programming from before using RX, for instance, you probably already know map, flat map, and flat map latest, compact map. Stream transformation is kind of like a combination of all these things together. So let's have a look at an example. What we're going to do in here, we're going to define a list of names. It's very simple. It's just going to be a list of 3 names, foobar baz. And we're going to create a stream that every second, for instance, picks a random name from this iterable. And then we're going to transform these names to uppercase every time the stream produces a value. So a very simple example of how stream transformation works in Dart. So let's clean up all the code related to person. So in here, really, we don't need anything related to person. So pretty much delete everything related to person, okay? Like that. And then we can leave and then we can remove convert and Dart IO as well. Great stuff. So what we need to do then is to go ahead and define our names. So I've already prepared that. So I'm just going to paste it in here. Nothing fancy, just a list of names, foobar baz. And what we're going to do also is to grab a random element from our iterable names. So I have a good extension on this. I'm going to write, let's say, extension random element t on iterable t. Okay. Then we say get random element. And we're just going to say elements at. And in here, we're going to say math. Let's import math. Import start math as math. And we go in here and we say math dot random, this next int, and we get current length of this iterable. So this is a very simple extension on iterable that I use quite a lot. And you could, it allows you to grab a random elements from any list or iterable. And that's going to be useful when we grab a random name from the names listing here, okay? So how are transformations done in Dart streams? They're in two parts. One is the sync itself, and the other one is a base. And the way it works is that you first go ahead and create a sync. The sync is where the values of your stream come into, as its name indicates, is a sync. It's like a placeholder. It is a holder of your values. So let's just say a sync takes in values of any kind, for instance, string, and then it does something with that value. So for instance, it can add that, make that value uppercase, and then add it to a string. So that's for the sync. The sync does the actual job of doing something with the incoming values of your stream. And then you'll need also a transformer base, and this transformer base hooks the stream, the source stream, with the sync. So it's a middleman. The transformer base is literally just sitting in the middle, as you'll soon see. So let's go ahead and write our sync. So we're going to go ahead in here and say we have a class. Let's just call this class, what should we call it? Uppercase sync. And this one implements our event sync. And then we say it's a string. So this event sync, actually, I think this is in Dart.io, if I'm not mistaken, or it's in Dart async. So we have to import that. So now that we've done that, we're missing a few implementation details in here. But before we do that, we actually have to define our event sync. So let's say event sync of string. And we call it sync. And then let's go and create a constructor for this, just like that, as a constant constructor. So now that you have an event sync in here, you can start playing with it. And in this event sync, you can read the documentation for it. It's kind of like where all the values of your stream actually end up being inside. So the stream itself doesn't contain the values, it's the sync, okay? So now that we've done that, we have to go ahead and define all these missing overrides, as you can see in here. And add, what we're going to do in add, you see we get the string, the incoming string, for instance, the name. Then we're going to say sync.add event to uppercase. So before we add it to the sync, we're making it uppercase. For the error in here, we're just going to say sync add error, to be honest with you. So nothing fancy in there. So let's go ahead, and for the add error, we're just going to say sync add error, and then we say error and then stack trace, just like that. So nothing fancy, okay? And for close, we're just going to close the sync. So sync.close. So that was like your basic implementation of your own event sync, maybe the first time you've implemented it as well. Then what we need to do is to create that transformer. As I told you, it's the transformer base, it's the stream transformer base, is the glue between an actual stream and your sync. So let's go ahead and say class stream transform uppercase string, something like that. Extends stream transformer base. Okay, and it takes in a string and returns a string, just like that. Okay, so if you want to have a look at this code, you can have a look at it now. So this is the name of the class, and this is what it is extending. Okay, for this to work, we have to have a bind function. So I'm gonna get Visual Studio Code to complete. Oh, see, create one missing override. This one. Okay, so this is an overriding that. Okay, so this needs to return a stream, and it takes in a stream. So let's go ahead in here, and we're going to say stream of string, then we say event transformed. Source is the incoming stream. So what we're using in this section of this chapter is really the use of the event transformed function on stream. So we say the source, given the stream, we have our sync. So we create an uppercase sync with that sync in here. Okay, and then we just return that. So you can have a look at this code again. Let me see if I can clean it up a little bit. Maybe put a comma in here. Okay, so it looks like this. You can see it's an override function called bind, and it takes a stream and returns a stream. What it does return is a stream event transform. Given that stream, it takes that stream's sync and we pass it into this sync in here, and we add the uppercase value to that sync. So it's really, you take a stream, grab its sync, pass that sync to another sync, and that sync is then going to play with the original stream sync. Okay. Okay, let's go ahead and put this to test. So what I'm going to do is I'm going to paste some code in here for the tested function so we don't have to write it by hand. Let's see what's happening in here. We're waiting for a periodic stream. I always have difficulty saying periodic. And it's repeating every second. And for every second is retrieving a random name from names you see here. So our stream is a stream of strings. Or more correctly, is a stream of string. And then we're calling the transform function on that stream, and we're passing our transformer instance to that transform function. Okay. And then we're waiting on that result, and we're just logging the result out. So let's bring up the console in here, and I'm going to do a hot restart of our application like this. And let's see the result. You can see now all the strings being printed to the console are all uppercase. And that's exactly what we expected, because we are doing transformation of the results, and we're using the transform function and our own stream transformer. Great. And that was really the results. We've already seen that, so we don't have to see it again. And you can be really creative here. I mean, if I told you, if I give you a stream and you have the ability to return another stream to me, you could be completely creative here. You could like transform any stream to another stream in here. So you can just go ahead and completely go crazy and change these data types and produce crazy values if you want to. So you have the chance to do that. So transformers return streams. You can be very creative with these and create other sorts of streams given any input stream, to be honest. So let's go ahead and commit the code that we've written in here as well. So terminal and git add all, and then git commit step 8, I believe. It's log, yes. I think git log says the previous step was step 7, perhaps. Yep. And then we will tag this as well. Git tag step 8. And if we look at all our tags, then we have, yes, 1, 2, 3, 4, 5, 6, 7, and 8. So these were really all the examples I wanted to show you in this chapter. So again, let's go over some of the concepts that I demonstrated in this chapter. If you want to think about streams in a way that makes sense, a lot of people I've talked to talking about pipes made it easier for them, because you can think of water running in a pipe and then connecting another pipe to your pipe, and then you can see water going into that as well. It's kind of like how hoses work, for instance, in your garden. If you have a water hose and you connect another hose to it, then the water starts flowing in there as well. So streams work the same way. Data flows in a stream, and then if you async expand that, create another hose, that data will then flow into that stream as well. So one thing that has helped a lot of people that I've taught streams and actually reactive programming with RX has been to look at a website called RX Marbles. And this RX Marbles, we can have a look at it together. It's very good for teaching reactive concepts. So I'm going to bring it up here. It is It is a free website that you can have a look at. And if we increase the size in here, you can have a look at some of the important concepts of reactive programming and streams, for instance. So if you are not familiar with, for instance, let's have a look at, do we have in here flats map, or perhaps we could have a look at merge. So in here it says if you have a stream that returns, like has a value of 20 in it, value of 40 in it, 60, 80, 100, and then it finishes here, and you can play with these marbles as well. And then you have another stream that, for instance, has a value of 1 and 2. If you apply the Rx merge operator on it, the result will be this. So you can play with these and kind of see, okay, if I have one stream and then that stream returns those values, and then I completed here, what happens to the result? You can see in this case, the merge continues until the second stream also dies. Hence, the value of 1 is also present in the stream. So I'm just thinking that if you're getting more comfortable with streams and futures, it would be really good for you to also understand reactive programming with Rx, for instance. And you can have a look at Rx Dart and have a go at it, and you will see how beautiful this whole world of Rx actually is. But that's outside the scope of this chapter. But I just want to introduce you to Rx Marbles because it also helps visualize how streams work. So let's just quickly go through some of the concepts. We talked about future. Future is a package of data that can be unpacked in the future, as its name indicates. An async function is a function that tells Dart that, hey, I want to execute some functionality asynchronously, but not necessarily. I may or may not. And suffixing a function with the async keyword allows that function in Dart to execute asynchronous functions or functionality using the await keyword. An async function marked as async asterisk is an asynchronous generator needing to return a stream of something. And marking a function as async asterisk in Dart makes it an asynchronous generator ready to use the yield keyword in order to insert data into its returning stream. And then, of course, the mother of them all, the stream, which allows you to return multiple values, or alternatively end the whole stream with an error inside the same pipeline. So I hope you enjoyed this chapter. I mean, we went through a lot of information. We talked a lot about streams and futures. However, I gave you 8 examples, and you may think, well, that's a lot. However, if you really want to get comfortable with streams and futures, I highly suggest that you go make up your own examples. Go ahead, make some APIs. You have the live server extension in your Visual Studio Code. Go ahead, make some APIs, link them together. Assume one of the APIs fails, or make one of the APIs fail inside a stream. See what happens. How can you catch those errors? How can you recover from errors? All these are so important when you're working with asynchronous and concurrent programming in Dart. So go ahead, make some examples for yourself. And if you have any questions, don't hesitate to ask me. Hope you enjoyed this chapter, and I hope to see you in the next one.